All right, so today we're going to talk about translations of linear functions. We're also going to talk about absolute values. A lot of definitions, but we're actually going to really worry about the main thing right here is this one right here is the K. All right, so the parent function, and that's basically like the base model of a vehicle. No extra bells and whistles. This is what it is. But if you get the different rims, get the leather interior, get the heated and cooled seats, and that is the translation. All right. So this graph right here is our parent function. Okay. And it says A. We normally don't worry about the A so much on this because we've already talked about slopes so much before now. It's really not meaningful. So we do talk about the K because that is actually part of some of the other stuff that we're doing. All right, now, this is going to be our main equation that we're going to use is y equals x plus k. And for k, if it's positive, it moves it up. If it's negative, it moves it down. Okay? K is the easiest letter in our transformations or translations. I like saying transformations because it reminds me of Transformers. Robots in disguise. Okay, so now this says draw the function. We're not drawing. And the reason why is because, believe it or not, we actually used to make people draw it and write this. And I think I took these from last year. I'm like, we don't need to draw this. We very rarely had anybody at this point in time when we covered this draw a linear function. Okay. But we are going to do this. So we're going to describe the transformation. So A is y equals x plus 4. So this is up 4. And you can actually do the arrow. Or you could say up 4. That's it. That's all you have to wrap. Super easy. All right. This is negative 5. So this is down 5. And then positive 3. This is up 3. All right. So basically, it takes that parent function and either moves it up or down. Yeah. Yeah. I'm sorry. I whited out I've actually whited those out because I didn't think they were needed. And I know y'all's on the handout might be a little different, but I've actually just taken let's see, if you look at mine now, I'm just not really worried about this right here because we've never tested that ever at this point in time. Ever. All right. That basically, in a nutshell, is linear functions. Ta-da! Now, on your turn, we're going to do it as an our turn because it's pretty easy. Now, if you see, I have both of these. They have y equals x on both of them. That's our parent function. Okay. So I'm going to add in this translation right here. It says a vertical shift down 4. So all I have to do is do minus 4. Okay. On B, it says a vertical shift up 8. So all we have to do is just plus 8. Pretty easy. Okay. Very rarely have we ever had people mess up on the linear translations. It has happened, but very rarely. All right. So I want to do this right here because it's going to take y'all a little bit of time to write it down. All right. Absolute value. Remember, it looks like a V. Okay, V for value. All right. And I know it says A, H, and K on here in different places. Don't really worry about that so much because I hadn't got to that part of the equation yet. Okay. But very similar to the quadratics that we had in Unit 9 and 10, that the y values are symmetric. okay? And we always have a vertex of H and K right here, and I'll go over that in a second. Okay, but this is where it really gets into this stuff down here, because here's your equation, this right here. Nothing's moving, it's frozen again. Oh, let's see, because this is where it messed up last time. And I'm still recording. Okay. All right. Hopefully it's better now. All right. Is that more better? All right, good. It's more better. All right. Now, if you look at that equation, it says minus H, okay? That's just the way it's given. And for some odd reason, when it says minus H, that actually means it goes right. When it's positive, it goes left. That's exactly opposite. I just remember they used heroin like Tylenol back then when they were doing this, okay? But, and we still have the K still does the up or down like we had on the linear, okay? And that's going to hold true for all these rules are actually going to hold true for the three things that we're doing this week on this, okay? And the A, it transforms it into, see, this is translate, translates, and transforms. Okay, I know what translations are, you know, English and Spanish and Italian and French and stuff like that. Transformations, I mean, that's what I think it should be. It's like Optimus Prime rollout. Okay, so when the absolute value of A is greater than 1, it's a stretch. And this doesn't mean a whole lot now because it's just, you know, it's words on the paper. It doesn't make sense, but it will here in a second because we're actually going to graph it so it makes more sense for what this looks like. Okay. And if it's negative, it's flipped. Now, a lot of people, a lot of other teachers will say I'm teaching y'all wrong by saying it's flipped, but they'll say, no, it's supposed to say it's rotated about the x-axis. Okay. If I waited for every ninth grader to say or write down rotated about the x-axis, I would die before all of them would actually do that. Okay. But this is what I think of it is. Y'all remember like playgrounds where people would go up on those bars, they'd go up, they hold themselves up on their arms and they would flip over. Yeah, kind of like a gymnastics thing. That's what I think of it is because it basically it takes it and just goes and flips it down. Okay. So on the back of your handout for y'all, we're actually going to graph this. Now, I had to move my face. This I graphed the parent function, okay, just so y'all can, you know, understand what it is a little bit more. Basically, it's just two lines starting at the origin going that way with a slope of 1, okay? Now, one thing I like to do each time, just like in quadratics, I'll always find my A, B, and C. I like finding my A, H, and K, okay? And they're in alphabetical order as they show up. So my A for this one is 3. All right, it's positive, so our direction it opens up. Now, our slope is actually 3. This is actually our slope right here, and it will make more sense in just a second. And we have the transformation because A is greater than 1. We have a stretch of 3. Okay, so we have a stretch of 3. Now, our H value is normally in here with X, but we just have X standing right there all by itself with the absolute value sign. So our H value is actually 0 for this one. Okay, there's no numbers in there, so it's just 0. So that tells us that our X value for our vertex is also 0. And then K is -6. Well, that means that a -6 goes here. And on our transformation, see, transformations, which one is it? Okay, it's actually down 6. Now, all this information is good here, but let's put it to actually where it's visible, okay? So I'm gonna use this hot pink color. I'm gonna go to 0, -6, and make my dot for my vertex. So 1, 2, 3, 4, 5, 6. All right, so there's my vertex right there. Now, this A value is 3. Now, just like quadratics have a ratio of 1A and 3A, our absolute values have a ratio of just 1A. So this is what I do. From here, I go over 1, up 3. 1, 2, 3, make a dot. Over 1, up 3, make a dot. Okay? Now, it's also symmetric, so I have to do it by the other side. So I got to go over 1, up 3. Over 1, up 3. Now, I have 5 points. Remember, that's all I require for y'all to do is 5 points if you have to graph. And this is what it looks like. Okay, so if you really compare this, the parent function in black to the other graph in pink, translation, transformation, the pinkin, okay, it's been shifted down, it's been stretched out. It's almost like a rubber band. Like you take a rubber band, you stretch it, it gets longer and kind of skinnier, okay? And we're only dealing with vertical stretches. We're never dealing with shrinks, okay? That's something else. So if you see that maybe on homework assignment, no shrink, okay? So now this is our first one, okay? I don't expect you to understand it fully on this on our first one. It's like, how many of y'all have ever made pancakes before? Okay, the first pancake that you make, that's always kind of like that's the one that you eat before you like share with other people, right? Because it's not usually the great one. So anytime you do something for the first time, is like the first pancake. This is our first pancake. It's doable, but we don't really understand it right now. Okay, so let's look at number 2, and I'm going to write this up here so we still know what our stuff's supposed to be. All right, and I'm going to find my AH and K. So A for this one is -2. All right, because that's negative, that means it's going to open down. And our slope is going to be -2. Okay. Our H, remember that H is the opposite of what it's written. Okay. So it's not -2, our H is 2. H is the hardest one to get because the way it goes. Okay. Now, since we have H of 2, we put it right here. Oh, I forgot to do the vertical thing. All right, transformations, this one was flipped. And we have a stretch of 2. All right, and this is written as negative, so we actually go to the right 2. I'm sorry, I got behind on that. And then our K value is like this. Well, that's right here. We have -6, so -6 goes her. All right, and this is down 6. So now we actually have everything that we need to put this on the graph. Okay, am I frozen up there again? Okay, good. All right. So using the hot pink pen again, I'm going to go over to 2, down to 6. 1, 2, 3, 4, 5, 6. Bam! Okay, there's our vertex. All right, our slope is -2. So from here, I go over 1, down 2, over 1, down 2. And then again on the other side, because it's symmetric, over 1, down 2, over 1, down 2. So it looks a little bit better. Okay, now we're on our second pancake. Now the first one we didn't really, it was doable, but we don't want to show it to our friends. But this one, it's flipped. Yes, it opens down. It's stretched out. You can see it's a little bit skinnier than the other one. Okay, it's moved over 2 and down 6. So that's basically all it's doing right there. Okay, now you have a your turn right now. We're going to come back to this because I actually have to record it right now because it messed up in last class, but it's going to end up helping y'all out later. All right. So if you're watching this at home, just pause it and then go back. All right. There's your turn. We'll come back to that. All right. Let's look down at the bottom of the back of the page. We have these three things. All right. This is our h of x. Is this one right here? This is our f of x, and our g of x is this one. That's just a different way of naming different equations. Okay. You can't just say wow, 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 wow all the time. Unless you're a toddler and you're trying to understand something. Or if you're Mr. Jeffries and you just really don't understand something. Okay? That's supposed to be a joke. Y'all didn't laugh. Minus 2 points. All right. So, all right. Which one of these is our parent function? Which one of these goes through the origin? Say it again. H of x. Yes, yes, yes. All right. So that's h of x. Now, that's not going to have any transformations. So we don't have to worry about that right here. Let's go ahead and write that equation. We should know that this is that equation for that parent function right there. All right. That's our base model. Nothing's done to it. Okay. Remember, no leather seats, no heated steering wheel. All right. Our f of x. Well, it's been moved around a little bit. Okay. Let's look at our vertex right here. Our vertex is -3, 0. All right. This is our h, and this is our k. Now, remember from last unit when we were actually trying to find the a of the chart, well, we go from this y value to this y value. This went over 1, up 1, so our a right here is 1. Okay? And if we're describing this in our f of x, its transformations, I don't need to do an arrow because that's actually how we're saying our transformations. Okay? Well, this one's just moved to the left 3. So arrow, draw a better arrow, 3. Okay? And now we actually plug that stuff in here. Now remember this equation, h plus k. All right, so when we're writing this in here, I'm not going to do I shouldn't do a y right there, but I will just because I want to. All right, a is 1, so you don't have to write it down there. Okay, so here's absolute value x. Now, if h is -3 and this is a minus, remember minus a negative is plus a positive, so this means plus 3. Remember, it's backwards. They use opium like Tylenol. And k is 0, so that's it. All right. Now, g of x, this one's been moved around all over the place. This has a vertex, looks like it's at -3, and then down 4, so -4. So that's my h, that's my k. All right. Again, to find my a, I go up to this next y value up and over. So my a is 1. All right. So this transformation for my g of x, all right, I've went left 3 and I went down 4. Okay. Mr. Mackey. All right, so a is 1, so I don't have to write that right there. There's my absolute value sign. I plug in that -3, I have a plus 3. I went down 4, minus 4. All right, so I'm going to stop recording so my students here in class can go back and do the your turn. And for those watching video, good stuff, good things, and roll tide.